Another example, find a unit tangent vector and the parametric form of the equation of the tangent line to the curve. And here's the curve given as a vector valued function in component form, 2 sine of t, so it's like 2 sine of ti plus 2 cosine of tj plus 4 sine squared of tk. At the point P, given as 1 square root of 3 and 1, and our prime of t, taking the derivative of 2 sine of t, we get 2 cosine of t. Taking the derivative of 2 cosine of t, we get negative 2 sine t. Taking the derivative of 4 sine squared t, we get 8 times sine of t times the derivative of the inside function, which is cosine of t. So at this particular point, we would get t equal to pi over 6, noting that since 2 times sine of t is equal to 1, then sine of t has to be a half, and so that angle must be pi over 6. Just double checking, 2 times cosine of t comes out to be square root of 3, so cosine of t must be square root of 3 over 2, again at pi over 6. And just to double check, 4 times sine squared of t turns out to be 1, and sine squared of t, well, sine of t is a half, and sine squared of t is a fourth. 4 times a fourth is 1, so we get t equal to pi over 6. So r prime evaluated at pi over 6 would be 2 cosine of pi over 6, which is the square root of 3, 2 sine of pi over 6, negative 2 sine of pi over 6, which is negative 2 times 1 half, which is negative 1, and finally 8 sine of t cosine t. Well, sine of t is a half, cosine of t is square root of 3 over 2, so this times this is square root of 3 over 4, but the 4 and the 8 cancel, and it gives us just 2 square root of 3. So unit tangent vector there would be r prime evaluated at pi over 6 divided by its length, and its length, the length of this vector would be the square root of square root of 3 squared, which is 3, plus square root of negative 1 squared, which is 1, so 3 plus 1 plus 2 square roots of 3 squared, which would be 12, so we had 3 plus 1 plus 12, which is 4. Well, maybe I should say is 16, but remember the length would be square root of 16, so it's 1/4 times r prime of pi over 6. Here's that listed, so just copy and paste that in here. Now we can use the direction numbers, square root 3, negative 1, and 2 square roots of 3 at the point P, and we get parametric equations. X equals square root of 3 times t plus 1, y equals negative 1 t plus square root 3, and z equals the direction number 2 square root 3 times t plus 1.